So hello everybody, my name is Lik Kian. Uh, those are my two PIs. I'm a PhD student in my third year. And my first slide looks like the side of a race car. So I'm here to talk about aerosol impacts on hydrology and some of the further downstream impacts, particularly in the lower Mekong River region. So basically continental Southeast Asia. And so first I'd like to start by talking about why this and why this area. So this is a picture from IPCC showing the deviations from the mean precipitation over the last 100 years. So the red and blue lines are just like decadal averages, while the green bars show individual years variations. You can see that over the last 30 years, we're experiencing like more and greater deviations from the mean in both the positive and the negative side. So it shows that on a time basis, there is an increase in variability in precipitation in Southeast Asia. So aside from the time basis, we also want to look at the spatial variation. And so this image shows different precipitation indexes. So we're not going to look at all of them. We'll just look at the first three. Basically, this data is collated from rain collection stations throughout Southeast Asia over the last 30 years. And you can see that for total precipitation, we have maybe 4 to 5% of the areas experiencing an increase, a bit more than 5% experiencing a decrease. And what's more interesting is that for the number of wet days, a large number of stations show a decrease in the number of wet days over the last 30 years. This contrasts with the NICS index, which is the average precipitation from each wet day, which shows that we actually get a lot of increase in average precipitation. So what this implies is that even though the number of wet days may be decreasing, the amount of rain that falls in each wet day actually increases to kind of make up for it. So this is talking about more extreme variations in rainfall amounts. So what is the purpose of all this water? In Southeast Asia, we rely on water for a lot of things. We use it for agriculture, for municipal use, and for industry. So looking at just focusing on the mainland and maritime Southeast Asia, for mainland and Southeast Asia, most of their water use is drawn for agriculture. And this is interesting because they are also the highest, they also have one of the highest water consumption per capita. So we have a very high water demand. And so any fluctuations in available rainwater will affect them greatly. So what do people do to counter that? They build dams to have some sort of storage capacity for water and to generate power. So in mainland Southeast Asia, we only have 12% of the capacity of the region that is for dams, as opposed to the rest of the region. So you can say that Southeast Asia is dam sensitive to changes in rainfall. So not only do you use water, when you build all these dams to store the water, you also use it to generate power. So I compiled some data I found. Hopefully you can see the figures below. And this is looking at the total available, technically available capacity for hydropower in each of the, just 8 countries in Southeast Asia. For Malaysia and Indonesia, a lot of the potential is located on the Borneo side of the island. So there's problems with even if you generate the electricity, it's hard to transmit it over to where most of the people are. So we're focusing mainly on these 5 countries that are in the continental Southeast Asia region. And so one thing that all these countries have in common is that there is one river that flows through each of them, and that is the lower Mekong River. So just for comparison, this is Singapore's hydropower capacity. So why the Mekong River? First, it's kind of like the low-hanging fruit, right? Because it is a long river there is such a great hydropower capacity, more than 30,000 megawatts in the lower Mekong River alone. And for comparison, a coal plant burns, I think, 4,000 tons per year to generate 1 megawatt of power. So we're talking about a lot of, potential energy, potential coal that is not being burned. And, it is the world's largest inland fishery. The lower Mekong accounts for 84% of the flow and 79% of the catchment area of the, continental Southeast Asia region. So that's why, this area is very fascinating for us to study. So another interesting thing about the Mekong River is that the flow distribution varies greatly along different stages of the course. So in the upper two boxes of the lower, so basically, I should probably back up a bit and explain that the lower Mekong River is basically every part of the Mekong River that is south of China. So the Southeast Asian region. Anything north of that is considered the upper Mekong. So the first two boxes, they are from the they're from the upper streams of the Mekong River. They are dominated by mountainous forests that has slash and burn agriculture there. And a lot of their dry season flow comes in from the upper Mekong, but a very, very small amount. In the third course is where you can see the shape of the flow throughout the year start to change. That's because it is getting contributions from large tributaries from Laos. In the fourth box, the shape changes even more, and now you're getting contributions from Cambodia, and also that region contributes about 25% or a quarter of the total mean annual flow. And finally, you get right down to the delta, and you actually can see a strong, like a spring neap tide variation. So you get two cycles a month. So you have probably seen this slide before when Xianghe talked about the downstream effects of aerosol emissions. So what I'm doing is actually downscaling some of the runs that she's done into a high resolution cloud resolving, using WRF-Chem to a cloud resolving state, and then using the forcings from these models to drive WRF Hydro, which is a hydrological model to simulate like a soil moisture as well as river flow rates. And ultimately, what we're trying to do is to see how these potential changes in emissions can affect agriculture or power generation use. So the emission scenarios, we have seen this before. First one is being driven purely by fossil fuels, which represents sort of like a constant source of emissions. And then we got biomass burnings, which are kind of like large spikes with great seasonal variations. And finally, a bit of both. So when we downscale with the WRF-Chem, this is the huge outer domain. And then I'm zooming in another two downscale steps to look at the mainland Southeast Asian region. And we use resources from NSCC who to do all this heavy lifting. Right, so these are some early results from calibrating the WRF Hydro model being driven by some basic rainfall generated by the WRF-Chem model. So basically the measurements are the blue lines, and then the simulations come from the red lines that the model generates. So we look at various sections throughout the river, first the upper section, and then the middle section, and also the lower section. And we find that although the fluctuations may vary a little bit, in general we get the seasonality of the rainy seasons flow fairly well. And so moving on, further research, so I'll be looking at how the impacts of the different emissions show up in the cloud resolving models, both in terms of rainfall as well as shortwave radiation. And these changes, if they are different, how they affect stream flow variation throughout the year, because the land has a capacity for storing water as well, so it'll be interesting to see what changes. And finally, what impacts this might have on hydropower adoption in Southeast Asia is where we study, some potential feedback effects from burning, from having your, forest fires or fossil fuels. So that's the end of my presentation. Thank you.
Again, well within time. It's good that the humour was flowing and I felt swept away, quite literally. Thank you. So is there a question while Professor Altahia comes up? Any questions for Lik Kian? Okay, Stefan.
Hello? Right, so on the lower Mekong River, how much of the hydropower would be renewed by precipitation and how much could be taken by people upstream?
So overall, the lower Mekong River gets, I think, about 80 to 90% of its total flow from the lower Mekong itself. And so the upper Mekong only provides about, I think 16% of the water, and that is only during the dry season. In the wet season, there's almost like hardly any signal from there because there's just so much water in the Mekong River. So not much will get stolen.